So here's another video of graphing polars, and we're going to kind of compare these two graphs, r equals sine 2 theta and r equals cosine 2 theta, and we're going to come up with a couple patterns, not only between the difference of sine and cosine, but looking at this coefficient. So let's go ahead and start with this top one, r equals sine 2 theta. Went ahead and graphed it and marked out the important points. So let's go ahead and start that, starting at 0, 0, so it starts at the pole, at an angle of 0, going up to pi over 4, so pi over 4 is going to be this middle line, and it'll have a radius of 1. Once again, I kind of changed the units, so ignore these first three. One's going to be out here. And it's just going to be increasing from 0 to pi over 4, coming out tangent to this 0, and from pi over 4 to pi over 2, which is right here, it's just going to come back to the pole, always positive. So it's going to come in and come back in tangent to pi over 2. Okay, so now let's look from pi over 2 to 3 pi over 4. So we're looking from this angle right here to here, this area. Well, at 3 pi over 4, we have an r of negative 1, so instead of being out here, we're going to be on the opposite side, so we're going to be coming out here, and all the values are negative, so instead of looking from pi over 2 to 3 pi over 2 right here, we're going to be looking from here to here. And so it's getting more and more negative up until this negative 1 right here, coming out tangent to pi over 2 or negative pi over 2, whatever is easier for you to think. And looking from 3 pi over 4 back to pi, it's just going to go back to the pole. So instead of being out here, since all the values are negative, we're looking over here. And it'll just go back to the pole, coming in tangent to pi. From pi to 5 pi over 4, we're coming in from 0 to 1. So 5 pi over 4, that's over here, and 5 pi over 4 comma 1, that's this point. All the values are positive and it's increasing, coming up tangent to pi. So start out tangent and it'll look like that from 5 pi over 4 to 3 pi over 2, which is this line. Once again, all the values are positive, going back into the pole, 3 pi over 2 comma 0. And you guys can probably kind of see a pattern, but from 3 pi over 2 to 7 pi over 4, all the values are negative, going into 7 pi over 4 comma negative 1, so that's going to bring us to the opposite side. And all the values are negative, so instead of looking right here, we're looking right here. And it's increasing up to that, or decreasing up to negative 1, down to negative 1. And from 7 pi over 4 to 2 pi, once again negative, going back into the pole, so 7 pi over 4 is right here to 2 pi, so they're all negative, opposite side, going back into the pole. So that's a graph of sine 2 theta. Now let's do cosine 2 theta. Now I'm going to do this a bit quicker. We're starting at 0 comma 1, so it's going to be out here. From an angle of 0 to pi over 4, which is over here, it's going back to 0. And it's always positive and decreasing. It's going to look like that. From pi over 4 to pi over 2, it's decreasing to negative 1. Pi over 2 would be here. So pi over 2 comma negative 1 would be down here. Decreasing. So instead of looking at this area, we're looking at this area. So we're going to kind of come in like that. From pi over 2 to 3 pi over 4, it's going to go back to the pole. Instead of looking here, since it's all negative, we're looking over here. Coming in there. 3 pi over 4 to pi, it's going to be positive starting from 0 to pi comma 1, coming out tangent to 3 pi over 4 into 1. From pi comma 1, we're going to 5 pi over 4 comma 0, so that'll be this angle going back into the pole. And 5 pi over 4 to 3 pi over 2, 3 pi over 2 being here, we're going back negative 3 pi over 2 comma 1, instead of here would be here. And from 3 pi over 2 back to 7 pi over 4, all the values are going to be negative going back into the pole. So we're looking at from 3 pi over 2 to 7 pi over 2 here. Since it's all negative, we're looking at this area right here. So we're going to graph that. And 7 pi over 4 to 2 pi, all positive. You guys can probably finish this without even looking at the graph. And that's what I said. After a while, once you're graphing a bunch of these polars, you'll kind of notice patterns, and it'll make graphing a lot faster. So let's notice the difference between cosine 2 theta and sine 2 theta. Well, pretty much it's just shifted. And that's what's going to happen most of the time if you switch a sine into a cosine. You're just kind of going to twist it depending on the rest of the values. And let's look at one more pattern that we can see. This is sine 2 theta, and this is cosine 2 theta. If you went back to my other video, we graphed sine 3 theta. So let's kind of notice the difference. If you kind of think of this as a flower, sine 3 theta has 3 petals, and sine 2 theta has 2 petals. And what I think would be useful if you guys did was go ahead and graph r equals sine 4 theta and r equals sine 5 theta, and you'll see this pattern. But basically, what you're going to notice is that the amount of petals, and let's say we have r equals sine a theta, the amount of petals is going to depend on a. If a is even, like in what we did here, we're going to have 2a petals. So in this case, a was 2, we had 4 petals. If a is odd, we're just going to have a petals. So in this case, a was 3, and we had 3 petals. So that's a neat little trick to help you guys graph polars quicker. So if you guys do graph for sine 4 theta, you guys should get 8 petals. So it'll kind of be a bit more scrunched up. Each one of these petals will turn into 2 petals. And sine of 5 theta will turn into a flower with 5 petals. So that's a neat little trick to think about. And that's graphing polars.